In this video, we're going to look at determining functions from graphs. That is, if we've got a graph, finding the algebraic function that gives us that graph, represents that graph. We've seen before how to sketch graphs. If we're given the algebraic function, we can sketch the graph either in our calculator or without our calculator. This is going back the other way. If we've got a graph, can we find the algebraic function that gave us that graph? And the way we do that is, well, we're going to see how we do that by looking at these four examples. So the first example we see here is it has this nice parabola shape going through here. And the first thing we have to do is identify what type of function it is. And that's from the shape of the graph. This is a parabola, and we know that parabola is a quadratic function. Specifically for quadratics, there are two forms we need to be careful of. One is the vertex form, and one is the roots or factorized form. Now, we've seen that in a previous video. And this one, we have the vertex, so this is actually the vertex form. And remember that the vertex form is y equals a, x minus h, where h is the x-coordinate of the vertex, all squared, plus k, where k is the y-coordinate of the vertex. So for this specific one, we have y equals a, x minus h is the x-coordinate, so that's 1 squared, plus k is the y-coordinate of the vertex, that's 3. Now once we've done that, we have to work out the value of a, and the way we do that is using the other value we have, which in this case is the y-intercept of 5. Now, the y-intercept of 5, remember, is a coordinate 0, 5. It might not be the y-intercept we're given, it might be another coordinate. But it works in the same way. If we're given 0, 5, we know that y is equal to 5 when x is equal to 0. So we replace those two values into our equation, and then we can solve this equation. We get 5 equals, well, 0 minus 1 is minus 1, squared is just 1, so we get a plus 3. So a is 5 minus 3, which is 2. We mustn't forget the final step here is to write out the actual full function, which is y equals, or a is 2, x minus 1 squared plus 3. So that's the function that gives us that quadratic. Now, we could expand that if we wanted into ax squared plus bx plus c form, but you don't need to unless it specifies in the question to write it in that form. Now we're going to look at the second one here, and we can see the shape of the graph. We should recognize this shape of this graph as a cubic. And cubics are always going to be in root form for us. That is, we look at the three roots, or the factorized form. And here we have three roots, minus 1, 2, and 3 we're given. And what that means is it's y equals, we've just got our value of a, and then we're going to have three brackets in this case, squeeze that in, each one starting with x, and they're going to end in the roots, 3, 2, and 1. And the sign's always the opposite way around, so the minus 1 is plus 1, the 2 is minus 2, and the 3 is minus 3 inside there. So that's our general form, but again, we need to find the value of a, and again we do that using the other point we're given, which in this case is 0, 12, the y-intercept. So we substitute in what we know. 12 equals a, 0 plus 1, 0 minus 2, 0 minus 3. So that is 12 equals, we multiply these out, we get minus 2 times minus 3 is plus 6, times by 1 is plus 6, so we get 6a. So once again, we get a is equal to 2. And then we finally have to write out the full function, y equals 2, x plus 1, x minus 2, x minus 3. And again, you don't need to expand that unless it specifies in the question to give your answer in a specific form. Now on to the next graph. And again, the first thing we need to do is identify the type of graph we're dealing with here. And you should recognize this two-part graph is a reciprocal. A reciprocal graph. And the reciprocal graph always has the form y equals a over x, something over x. Again, we need to work out the value of a, and to do that, we use the point we know, which in this case is 4, 2. So we know the y-coordinate is 2, we have a, and we know x-coordinate is 4. With a bit of rearranging, we get a is equal to 8. And then substitute that value of a in, we get y equals, well, a is 8, so it's 8 over x. And that's our reciprocal form for this graph. The final example here, once again, we have to look at the type of graph we're dealing with first. And you should recognize this one as being an exponential graph. And remember that exponentials always have the form y equals a times b to the x. Although here we're dealing with p and t instead of y and x, so let's be proper. It's p equals a times by b to the t. And again, we now have to substitute the value we know. Well, we know two values here. But we've got two unknowns, a and b. So we're going to have to use both of them. The first one we're going to use, if we have it, is the y-intercept. Because that one helps us because it makes, in this case, t or x equal to 0, which is nice with powers. So through that point, we have that p is 400, so we have 400 is equal to a times b to the 0. But b to the 0 is just 1. So that tells us that a is equal to 400. So we have p equals 400 times b to the t. Now we have to use the second point, the 216, and substitute that in. And when we do that, this time we get 16 equals 400 times by b, and the x-coordinate is 2, the t-coordinate, is 2, so b squared. Now we have to solve this for b, so we divide by 400, and we get b squared is equal to 1 over 25 when we divide by 100, which implies that b is the square root of 1 over 25, which is a fifth. So now we found the values of a and the value of b, so we can write out our final equation, our final function. P equals, well, a was 400 times by b is 1 over 5 to the power of t. There are different ways to write that final one. For example, we could have written times by 5 to the minus t, or 400 over 5 to the t. They're all the same thing, but that's absolutely correct. So that's how we go about finding functions from graphs. We determine which type of function it is from the shape of the graph and our knowledge of the shapes of graphs. And then we write the general form of that function and substitute in points to work out any missing coefficients that we need to calculate.